Good afternoon. Science and technology revolutionize our lives, but memory, traditions, and myth frame our responses. I welcome all the participants. I welcome you all for 71st episode of Creative Session. Myself, Supriya Naika, hosting this program. Science and technology have played a critical role in the evolution of human society. Humans have a desire to observe and understand nature since prehistoric times in order to control and manipulate nature for their own benefit and welfare. Since ancient times, Indian has had a glorious culture of education, science, and technology, and has made significant contributions in the field of astronomy, arithmetic, geometry, metallurgy, the Ayurvedic science of medicine and surgeries. In today's session, we are going to learn more about S.T.E.M, science, technology, engineering, and mathematics concepts in ancient India. Before going to start, I like to brief about Creative. Creative is a group of people who are eager to gain new knowledge. Creative. Cre means creativity. Active means activeness. To be active, we need creativity. Knowledge Square is our tagline. Sharing of knowledge increases our knowledge. Main vision of Creative is to build constructive thinking in various domains. Our main focus on non-textual, non-academic, and non-syllabus related concepts. We invite subject experts every week to share their experiences, work with interested audience. We thank all our resource persons for accepting our invitation and engaging us with their knowledge. Every Saturday around 3 to 4, we organizing online talks on Zoom platform, and also we live stream our program on our YouTube channel Creative GVD. Today's topic is S.T.E.M concept in ancient India. To present this, we have Sridevi Bhatt ma'am with us today. Sridevi Bhatt is currently working as a scientist in U.R. Rao Satellite Center, Bangalore, one of the centers of ISRO. She completed her schooling and PU in Bangalore. She completed her BTech from Indian Institute of Space Science and Technology in Electronics and Communication Engineering with a specialization in avionics in 2018. Subsequently, she joined Liquid Propulsion System Center, Thiruvananthapuram from August 2018 till June 2022. Currently, she working in URSC Bangalore. She interested in different fields like Carnatic, classical music, Sanskrit, and chess. It's my pleasure to welcome you, ma'am. And I welcome all our creative associates, volunteers, and participants for today's session. Over to you, ma'am.
Good afternoon. Good afternoon to all of you. It is very nice to see that many of you have joined the talk and preferred to listen to a talk on Saturday afternoon rather than taking a nap. So thank you all for joining, and I hope to make it worth your time. Before I begin, I would like to thank the entire Creative group for giving me this opportunity. And special thanks to Supriya ma'am and Srinath sir for this. And thank you to all of you for attending this event. Creative has organized many talks from speakers who are very accomplished in their areas. Before this also, with respect to ancient medicine and concepts of Veda and science were covered in earlier talks. I should give a disclaimer that I am not an expert. I'm just a novice or a beginner. I have not really studied all these ancient texts, but whatever little I know, I'll be sharing with you. So yeah, let's begin. I'll try to share my screen.
Visible.
I hope that, yeah, okay, thank you. So yeah, let's begin. STEM concepts in ancient India. I'll be talking about this. STEM is actually an acronym or a short form for science, technology, engineering, and mathematics. The first letter of each: science, technology, engineering, and mathematics. In ancient India, many of these concepts were covered in various different texts, and most of them were in Sanskrit language. Be it various reasons that many of these scientific concepts are not aware to us, or it is not as popular as other scientific discoveries which were coming from the West. So this has kind of led to a belief that most of the scientific discoveries or inventions is done by the West. I'll just be sharing a few concepts just to give a glimpse. Let us begin. I'll try to cover all the areas and give small examples and probably explain one or two concepts in detail. So, ancient Indians had made significant contributions in various fields like astronomy, metallurgy, Ayurveda, plastic surgery, and so on. And works of people like Aryabhata, Brahmagupta, Bhaskaracharya, etc., are very well known, and they are very revered also. With respect to astronomy, there were many concepts which were given by Indians, but not very popular. For example, rotation of Earth on its own axis, and then heliocentric theory, which means to say that sun is the center and the planets revolve around the sun, and concept of gravity. So while explaining the rotation of Earth, Aryabhatta tries to explain it in a very compact shloka, and he gives a comparison also. I'll just tell that shloka. Anuloma gatir nausthaha pashyatyachalam vilomagam yadvat achalani bhani tadvat samapaschimadani lankayam. Meaning, a person who is sitting on the boat and moves in a river, he feels like the objects, the supposed to be stationary objects on a bank, they seem to be moving backwards. Similarly, we see, although the stars are stationary, we see that stars are moving. So by giving this kind of an analogy, Aryabhatta tried to explain the rotation of Earth on its own axis. Then coming to mathematics, it is well known that zero, or the significance of zero, was emphasized by Indians, and this later helped in various mathematics like arithmetic, and not only in this arithmetic area, but in also other branches of mathematics like algebra, geometry, trigonometry. Our ancient Indians have done significant contributions. I'll explain one of the concepts later in the slide. Coming to areas of botany, classification of plants, and the knowledge of osmosis, photosynthesis, etc. were mentioned. For example, in similar to what we know as herbs, shrubs, and trees, similarly in botany in those days, the plants were classified as Vanaspati, Guma, Lata, Gulma. like Vanaspati means herbs, and Brumas mean trees. Then Lata means creepers, and one with bushy branches called gulmas, like shrubs. The concepts of photosynthesis and osmosis were even known during the times of Mahabharata. Maybe we now know that these seedless fruits and vegetables are what to say, a significant contribution of modern age. But during those days itself, in a text called Upavana Vinoda, there was mention of seedless fruits and how to get seedless fruits, like the procedure to obtain seedless fruits. With respect to medicine, Ayurveda was the practiced medicine system, it is also being practiced in this day and age. It has various branches catering to various kinds of treatments, like full body treatment called Kaya Chikitsa, then Shalya Chikitsa, meaning surgery, and so on. I think it was covered in detail in previous talks by various resource persons. And even in case of metallurgy and architecture, lot of contributions were made. Coming to the field of mathematics, Aryabhatta, Brahmagupta, Pingalacharya were the famous mathematicians known in those days. We are well aware that zero was introduced to the world of mathematics by India, Shunya or zero. It is recorded that Aryabhatta has introduced it, but probably even during earlier days, there used to be mention of zero, but formal records show that Aryabhatta has introduced it. He has mentioned it in his book Aryabhatiyam. And Brahmagupta, another mathematician, in his grantha called Brahmasphuta Siddhanta, he showed zero in various arithmetic operations. Another mathematician, Pingalacharya, he is said to have introduced binary system, and he was actually a poet as well as a mathematician. In his work Chandas Shastra, he is said to have introduced binary system. Binary system is in use these days also for various computations. So basically, from zero to geometry, Indian mathematicians have done some great historical achievements. Now, zero has been introduced, and the next thing which we can tell is powers of 10 were also in use. Powers of 10, which we know in current day and age used for scientific notation, they were the powers of 10 were called as Dasha Gunottara Samjna, meaning 10 times before the preceding number. It means to say that the base is 10, and when you multiply by 10, you will be getting higher numbers. Actually, there is a beautiful shloka which compactly tells about these powers of 10. That is, Ekam Dashashatam Chaiva Sahasramayutam Tatha Laksham Cha Niyutam Chaiva Kotirarbudameva Cha. The shloka continues. If I have to tell the meaning of the shloka, Ekam Dashashatam Chaiva. You start with Ekam. Ekam means 1. Dasha Shatam. So the next higher 10 will be Dasha, that is 10. You multiply it by 10 again, you get Shatam. So when you keep on multiplying it by 10, the next number will be 100 into 10, that is Sahasram or 1000. Next, when you again multiply it by 10, that becomes Ayutam, that is 10,000, so on. So the shloka continues and goes on to mention various numbers. The highest mention of the power has been 10 to the power 53. 10 to the power 53 is called as Tallakshana. I have mentioned a few names of the corresponding powers. Like here, 10 to the power 4 is Ayuta, then Koti, Vrindam, Tallakshana. As acknowledged by famous scientist Albert Einstein, we owe a lot to the Indians who taught us how to count. If we really did not know how to count, then the modern scientific discoveries would have been impossible. As I mentioned, the highest power was, which was mentioned during those days, was 10 to the power 53. During the contemporary days, the highest power known to Greeks was just 10 raised to 3, that is myriad, and Romans 10 raised to 4 milli. Another contribution which we can mention is finding out the approximate value of pi. So Aryabhata gives this short shloka to tell how to give this value. I'll explain the shloka. Meanwhile, you can probably check the values with calculators as well if you want. Chaturadhikam shatamashta gunam dvashashtistatha sahasranam ayutadvaya vishkambhasyat asanno vrittaparinaha. So chaturadhika shatam. Chatur means 4. Adhikam means you add. To shatam. So you add 4 plus 100, which becomes 104. Then ashtagunam. So you have 104 right now. You multiply it by 8. Guna means multiplication. You multiply it by 8. So 104 into 8. You will get one number, that is 832. For that, you add 62,000. Dvashashti sahasranam. 62,000. So you have 62,832. And in the last line, he tells Ayuta Dvayam. As I mentioned earlier, Ayuta is 10,000. Ayuta Dvayam means 10,000 into 2, that is 20,000. So we have two numbers now, 62,832 and 20,000. He tells how these numbers are related. So 62,832 happens to be the circumference of the circle with diameter 20,000. So circumference by diameter, like by inference, by adhyahara, circumference by diameter, that you will get the pi value. He tells it is a asanna value. Asanna value, not probably the exact one. You get an approximate value of 3.14. So with very compact shlokas, they have tried to express a lot of information. Another contribution, another way of referring numbers is the Bhuta Sankhya system. It was an alternate number system commonly used in ancient texts while referring to some shlokas. This concept was actually extensively used by Pingalacharya in his Chanda Shastra. For example, like to the right, you can see the shlokas. For 1, referring to the number 1, he tells, Shashi Soma Shashankascha Indus Chandra Kalanidhi Raja Vithu Sudhamshascha Yama Eka Janastatha. So for referring the number 1, the names of moon or synonyms of moon, Raja, Yama, these kind of alternate words were used to refer to the number 1. Similarly, to refer to the number 2, eyes. Usually we have 2 eyes. That is why the coordination is made in that manner. The second shloka is Akshi Chakshu Karo Netram Lochanam Bahu Karnakaha Paksha Drishti Dvayam Yugmam ambakau nayane kshani. So 2 eyes, taraha, 2 hands. All these are synonyms of further. All of them are synonyms of eyes. Then paksha, wings, 2 wings. Yugma, the couple. Nayanekshana, all these are synonyms of eyes. So eyes, hands, 2 like bahu. So all these are used as alternate terms to refer to the number 2. Similarly, 3 gunaha, lokaha, chatur vedaha. So this kind of reference system also has been used. I'll just touch upon this Katapayadi Sutram. Katapayadi Sutra was another method of encoding used back in the days. Like how we know Vyanjanakshara, like Kaka Gaganga Chacha Chachana, like that. So this is Katapaya, Katapayadi Sutra. They have used the references of these to do the encoding. Not only in the field of arithmetics, even in case of geometry, there were significant contributions. Actually, whatever we know as Pythagoras theorem in our maths textbook, it has been already explained by Baudhayana in Sulbha Sutra. So essentially, the square of the hypotenuse is equal to sum of the squares of the other 2 sides of the triangle. This has been already mentioned by Baudhayana. Brahmagupta is another mathematician who also has done significant contributions to the field of mathematics. Just to give one example, how to calculate the area of a cyclic quadrilateral. That also it has been given in the form of shloka. Thula phalam trichatur bhuja bahu pratibahu yoga dalaghatah bhuja yogartha chatushtaya bhujonaghatat padam sukshma. Actually, in this shloka, he tells both the gross area and the exact area. Thula phalam means gross area. Sukshma phalam means exact area. We'll directly go to that exact area. So I have kept the translation on the side. The exact area is the square root of the product of 4 sets. 4 sets of half the sum of the sides. So basically half the perimeter diminished by the sides. So you have half the perimeter, sum of the sides divided by 2, diminished by the corresponding sides means minus the corresponding edge length. So S is semi-perimeter minus corresponding side minus B minus C S minus D. So this is the formula which we are currently using also for the area of cyclic quadrilateral. Now coming to few concepts in chemistry. Actually, during ancient India times, chemistry was practiced as an enabler for manufacturing zinc, copper, and different kinds of alloy. And it was also used for juice extraction in preparation of various medicines in Ayurveda. So for all these kinds of processes, great attention was given in the details for temperature, pressure, and so on. In different texts, there is a mention that Indian chemists were using around 32 different kinds of apparatus for their experiments. These were called as yantras. Few few of the yantras or the kinds of furnaces are Koshti yantra, Dheki yantra, and Tiryak Padana yantra. I'll just explain one of them here. So the image which we can see in the right top, this is a common image which we see in our science textbooks when they talk of distillation. You take a mixture in a round bottom flask, heat it, and the vapors are condensed on the right hand side and collected in a receiver where there is a cold water bath. In a similar fashion, this has been explained by a chemist called Vagbhata in his grantha called Rasaratna Samuchaya. So he tells, Chipe drasam ghate dirghe natadho nalasu sanyute. Chipe drasam ghate. So you take the chemical in the vessel which has a long tube. Tannalam nikshipet anya ghata kushyantare khalu. So that vessel which has a long tube has to be kept such that it is entering a receiver, like it is mentioned in this image below. Tatra rudhva mrida samyak vadane ghatayeradha athastad rasakumbhasya jwalaye tivra pavaka. So this arrangement has been made and the joints should be closed. It has to be sealed with clay and cloth. Now it has to be jwalayit. You have to heat it with tivra pavakam. You have to heat it with fire. Itarasmin ghate toyam prakshipet swada shitalam. The other vessel has to be cooled down with cold water. So tiryak patana metadhi vartikair abhidhiyate. So this setup is called as Tiryak Patana Yantra. Just by dividing that name, Tiryak means plant, Patana means made to fall down, Yantra means device. So it is like slant device which is making the chemical, vapor to fall down. So these kinds of processes were extensively used for various kinds of activities. One such activity where these kinds of distillations were used was during extraction of zinc. This has been mentioned in a book called Rasaratna Samuchaya. As a proof, we can see that when excavations were made in Zawar mines in Rajasthan, they found that zinc was being produced here. And the rightmost picture here, it shows zinc smelting furnace or the Koshti Yantra, the one which I had mentioned earlier. First, Koshti Yantra for distillation process. So this also shows that whatever we have seen in the text, what was also proved by these kind of excavations. So zinc was distilled more than around 2000 years ago through these kind of highly sophisticated methods. And the Zawar mines in Rajasthan helps prove in this regard. Then coming to various fields in metallurgy, ancient Indians used various kinds of metals and alloys for their applications. And India has heritage in the works of be it gold, silver, bronze, and so on. And there are mentions in ancient texts about metal work in texts like Rasendra Sara Sangraha, Shilpa Ratnam, Rasaratna Samuchaya, and so on. They have even mentioned making of lead shots or granules. It was actually a crude method, but these lead shots were used like bullets for punishing thieves in ancient days. Another marvel which we can see even today is the Mehrauli iron pillar, which we are aware that it has been rust free even after thousands of years. So, the kind of technology which was practiced back in the day um, is a testimony to the fact that it was a superior technology, and it has been this pillar has been rust free for around more than 1,500 years. So when metallurgists from IIT Kanpur discovered wanted to find out the reason behind this, they found a thin layer of misawite, a protective compound which has formed over this to prevent which is preventing rust from happening. So other than this, there are also descriptions of various kinds of crucible, around 407 crucibles described in various texts, which can be used for good or coarse metals, and furnaces to handle these molten metals, different classes of blowers, and what is their suitability of use. Added to this, there are mentions of making metal powder, process of obtaining highly shining slurry of gold. This can be seen when in case of few idols which are made using gold. Then coming to the area of engineering, civil engineering or architecture was one of the prominent areas where the ancient Indians significantly contributed. So this actually was highly developed during those days. It is evident today from the various kinds of temple architecture we see, the royal palaces, then various town plannings which were discovered during the times of civilization. There are various texts or shastras which deal with this, like Vastu Shastram, Bhugu Samhita, Kashyapa Shilpa, and all. So these explain the concepts how building construction should be carried out. The steps show that the approach was quite scientific during that time. So it tells the process should start with soil testing. Purvam bhumim pariksheta paschat vastu prakalpayet, which means first you test the earth or the site where construction is planned. After that, plan the construction. Then what kind of soil testing has to be done? What kind of parameters have to be evaluated for the soil? Like Varna Gandha Rasakara Shabda Sparshanairapi Pariksha Eva Yatha Yogam Iniya Dravyamuttam. After evaluating all the parameters, one should proceed with the construction. Then making of bricks, like Ishtaka. Ishtaka was called bricks. Ishtaka Sangrahanam. How it has to be carried out. The different kinds of clay which can be used and which kinds of clay is suitable for making those. And what processes have to be followed for the preparation of the same. Then usage of mortar. All these kinds are explained in texts like Maya Matam, Kala Moola Shastra, and so on. In his book, the author Teresi mentions in his book called lost discoveries, he tells that Indians knew how to build bricks, which not only could last a few years, but also thousands of years. Actually, these bricks were found as ruins during Harappan civilization, and it is a testimony to the fact that it was being used extensively during those times. The next stage would be assembly of pillars. They call it as Thamba Sandhyaha, different kinds of pillars, how they have to be assembled. Meshayudha, Trikhanda, Saubhadra, Mahavratha, Ardhapani, and so on. Another uh, proof we can see with respect to ancient architecture is the temple architecture which we see around. It speaks volumes about the knowledge which was prevalent that day. For a temple construction, usually stones are the main ingredients. So these texts elaborate how different kinds of stones are there, how they are classified. They categorize them into 6 different classes, like Tallika, that is Saikata means sand, so sandstone. Then Samavarna, uniform colored stone, or Hiranyaretika, if stones have certain gold lines. So on, classification goes like this. After these are classified, they tell out of these varieties of stones, what is preferred for idol making. The Samavarna stone, the one which has a single color, a uniform black color, or a dark brown, or a yellowish tint color is suitable. It has to be devoid of any pores or holes. This kind of good stone should be used for the main idol. If it is just sculptures on the wall, a different kind of stone is also okay. For constructing altars or posts, then sandstone also can be used. Another attraction is the carvings in these temples. So the various kinds of tools or the chisels that need to be used for carving these and how to use them. All of these have been explained. Not only temple constructions, but also efficient town planning was prevalent during those times. This planning has been uh, interpreted from shlokas in ancient texts. So it shows that there was road planning, drainage system, construction of bunds, or housing rules. Housing rules that they are mentioned over here. So even Kautilya also mentions the kinds of rules to be followed for housing. So all of this is just a glimpse to show the kind of concepts, implementations which were there back in the days. I have referred these sources for in case of detailed reading. If it kindles your interest, you may refer these. So to conclude, we can tell that traditional Bharatiya Jnana Bhandara contains a reservoir of knowledge in various disciplines, be it STEM or non-STEM like music, art, literature, and so on. So it is up to us to make optimum use of this knowledge. If we don't use them, then it is our loss. So for correct and proper understanding of these texts, knowledge of Sanskrit is absolutely essential so that we can have a better understanding of what is written. Knowing our history is the first step. So by understanding this, we should proceed further to do significant contributions in various different fields of our choice, interest, and so on. With this, I'd like to conclude. I thank the Creative Group once again for giving me this wonderful opportunity. And thank you all for patient listening.
Thank you, ma'am. Any questions? If any questions, please. Srinath sir.
Madam, good evening. It was a very good talk, very balanced talk. Just one or two example of one of the discipline which is continued and discontinued from our the reservoir of ancient knowledge. Any one example where even today we are practicing some of these knowledge, or one knowledge which is discontinued.
Okay.
I think you got my question, right?
Yes. So with respect to continuation, with respect to mathematics and calculations, we have been shown that various calculations which were done during ancient days, be it the value of pi or the calculation of astronomical distances and so on. But the continuation with respect to that has been confirmation using high-tech instruments. Like now they have been able to calculate the exact astronomical distances or the most nearest value of pi and so on. So this I would call it as a continuation of this knowledge. With respect to I would like to call it as a continuation or an improvement in that field. And with respect to stopping, I think it is mostly with respect to our architecture, I feel, because we have probably evolved different kinds of methods, or we have not been able to fully understand why architecture was done in those different ways. Maybe it was too scientific in that region. I am not sure if it's a very convincing answer, sir, but this is my opinion in this regard.
Thank you, madam. Thank you.
Any questions? Ganesh, you can ask the question. 1 minute, just you can unmute yourself and ask the question. Ganesh.
Madam, can we know the famous Indian architectures?
Ma'am, you are muted, ma'am.
Okay. By architectures, you mean to say the people or their work?
Both.
What I understand from whatever limited learning I have done so far, these people, the authors, I have mentioned here. Manasara is actually authored by a famous sculptor. Has it stopped here?
Yes, ma'am.
Share it again.
No, it's all right. Manasara, the person who has authored Manasara. I'm not remembering his name. He was a famous sculptor. And I am not able to recollect his name, sorry. The person who has authored Manasara. And Kashyapa Shilpa also. The authors of these were known to have experience in their field, but not able to tell their exact things.
Thank you, ma'am.
Okay, thank you.
Sita ma'am.
Thank you.
Ma'am, you muted, ma'am. 1 minute.
Thank you for the very excellent talk, Sri Devi. Just wanted to ask you one question or two questions rather. One is, when you say talk about ancient India, what is usually you consider as the time period over which it's considered ancient and maybe medieval and so on? That is one thing. And second is this heliocentric theory of the solar system. By whom was it proposed, when, and did it have connections also like in the Western countries? Did it have impacts on the religious beliefs at once this was done, or was it disconnected?
Yeah. Ma'am, I'll answer your second question first with respect to heliocentric theory. With what I understand is we have records showing that heliocentric theory was mentioned, or sufficient records with respect to Aryabhata in his book Aryabhatiyam, when he mentions sun is the center. But yes, as you mentioned, in case of Western culture, there were repercussions when this kind of theory was proposed. But what I believe, or what I understand, is although Aryabhata mentions in his book, I believe that it would have been there earlier as well. That's why repercussions would not have been there, is my thing. But I don't have any what to say. I might be wrong as well. I'm not completely sure. But maybe just the records say that Aryabhata has mentioned this. It would have been there earlier as well, which would not have led to any repercussions. This is my answer. And with respect to the timelines in ancient, with respect to timelines telling Aryabhata and earlier, the periods of Vedas, the dating of Vedas and Aryabhata. Here, so far, I have considered it as ancient, but I do understand your dilemma when I mention the temple architectures, which have been dated like just a few hundreds of years back. So exact per se, I'll have to check it, ma'am, the exact year which I'm referring to. But relatively speaking, the Veda period and Aryabhata contemporary time I have considered as ancient. And although I have deviated a little bit while referring to architecture, which is relatively recent compared to that.
Yeah, thank you, Sridevi. That was not, it was not meant to any question you or anything. It was just that, is there historical, because we don't know much of history.
Yes, definitely.
So is there a line drawn by historians saying up to say 1000 AD is ancient and after that is medieval, etc. For particularly for science is what I'm saying. There might be some definitions like that for social beliefs, That we know. I mean, in sociology, there is this thing called medieval India and so on. But for science itself is there, because we many of us don't know. That's why I asked this.
Actually,
Question.
when I read, you were right, ma'am. When I read about it, there were two to three conflicting timelines which were mentioned. Around the earliest, which was mentioned for Brahmagupta, was around 628 BC or so. But there were other narrations as well, which is why there was a little bit of confusion. So
no, I understand, because in India there is also this names, and of course even in the Western countries there are these names which are repeated, right? And
correct. Yes.
We don't have 1, 2, etc. often. So it might the confusion may also be due to that. Because
I want to say one
people
point
often
here.
take the grandfather's name and so. So that's
correct.
okay. Thanks a
I
lot,
want to say
Sri.
one point. I want to say one point here with respect to heliocentric, which Sridevi has rightly pointed out. Aryabhatiyam talks about it. Aryabhatiyam also talks about the nature of eclipses and the description of how eclipse happens. If Aryabhatta has successfully explained, after post Aryabhatta period till 16th century, people still believed in Rahu Ketu capturing thing only. See what might have happened at some point of time. Aryabhatta books were also not considered and ignored. That's maybe reason people have not believed it. See, eclipse, coloring happening, everything he has written in that on how color happens, all those things written. But now we are seeing it after modern science explanation, we are going back it. But some maybe 800, 900 years of time scale, nobody has looked at these books. That's what I feel. Maybe because of that, heliocentric was written in Aryabhatta, nobody has looked at it. After the modern science, what you called advancement, people started looking back the theories given by our ancient people, try to connect it. That may be one reason.
Yeah, that's why I said there might have been a disconnect between, in those periods also, between the what we term as scientists, but actually they were mathematicians. They were probably gurus and so on, and they probably were not intimately connected with the religious practices, which was left to probably the priests who were with the kings. And so that disconnect might have been there. Yeah.
Yes.
Ritesh?
Ma'am? Ma'am, that Brahmagupta you told, no, he told about the laws of gravitation, and Varhamira who told about the earth revolve around the sun. But in ancient time they invented like this all. But now they are telling gravitation was invented by Isaac Newton, and Varhamira was sun, with sun earth will revolve. They are telling like Copernicus and Galileo. Ma'am, why they did not mention Varhamira and Brahmagupta in textbook? They mentioned Isaac Newton and Copernicus. Sir, why they can't mention?
Yeah, it is very likely. Like just now we had a discussion, no? Probably for a long time, they were aware that these discoveries were made, but for maybe around 700 to 800 years, nobody really took efforts to make it popular or to make it aware for the common public. And that is why when Westerners started thinking, they had to look back or they had to put their names for the corresponding discoveries. So now at this point of time, everybody has accepted or accepted because it has been recorded in a recent time and it is popular. The Westerners are Copernicus for that theory and so on. It has become more of a, what to say, everybody has acknowledged it. It was probably our mistake that we did not keep it alive for a long time. Had it been kept, then till date in our textbooks we could have seen these names instead of corresponding Westerns.
Yes, ma'am. Can you change?
Added to it, Ritesh, added to it, what madam said is, any science, if you say, there is a phase called as development of a science. What the ancient days, they have written only 2-line slokas. But if you ask science, it has to go for an equation, mathematical expression, description, assumption, proof, theory. This is the development of a science or a mathematics post 16th century. So you cannot say that Isaac Newton is wrong, they were only right. Not that way. Concepts were there, development of concepts were halted. Whereas Isaac Newton is revered as a father of modern science. So he has developed a lot of theories by giving a proper justification, equation, which was not there. Whatever madam has told the value of pi in 2 slokas, can we today still accept the same thing? It was concept beautifully given. But now the pi has been much developed. We are writing now 1 kilometer value of a pi, you know it. So how is it possible in modern days? That is a development matters. So Isaac Newton is considered as a father of whatever gravitation, all those things. Writing 2 lines with respect to our ancient people, writing 2 lines is a concept given those things. But development has happened post 16th century all over the world. Even our own people, Vishweshwaraya, who was working in Bangalore, he was involved in gravitational wave detection theory. So like that, people have developed over the years. This disconnect what Sita madam was telling. Later in the modern area, Indians are also connected with Western. Everybody, science is everybody's, not only India.
Yeah, one more point I would like to add on that is that just imagine now you're all connected with all this Google, etc., etc. You know what is happening anywhere in the world through all these means. But those days, just imagine we were not in islands, but civilizations were like islands. And it is only through travel, through exchange of people that civilizations were interacting. Yeah. So some things went from here to Arabia, some things came from there to here, etc. So there was an intermingling. But I think one more aspect is because these texts were in Sanskrit, and because Sanskrit is not learnt by all, it was not a common language like we learn English, right? So it was not learnt by all. And third point is Sanskrit per se as a language can be interpreted in more than one way. And that is one reason I think very only people felt only very learned people can understand these things. I think that might have also prevented Indians to actually understand this and inform to the whole world that indeed this was already done. Because, yeah, so that is one more aspect which might have held back this thing. Does that satisfy you, Ritesh?
Ritesh, I hope that answers.
Ma'am? Ma'am? Ma'am, can we make like Indian philosophy as a Greek philosophy? We has like Democritus, who has like Kautilya, Chanakya, who was named, and we has like Aristotle. Can we make Indian philosophy as great to the world?
Ritesh, I think it already exists. But the way forward is we learn about it and move on to make better or more evolved philosophies. I think you're referring to that only.
Ma'am? Can you repeat?
If I can suggest, I'm Satyajit. I think what he is basically trying to say is that why it is not popular. I mean, Greek philosophy is popular. He's saying why can't we also make it popular? That's what
Yes,
he's trying to
yes,
say.
yes, yes. Definitely. Actually, making it popular will be our responsibility. So it is up to us to learn or to help it to help and make it simplified so that a lot of people can learn about it. Making people aware through teaching or talks or some other means of sharing knowledge. I think this is a method where we can make it popular.
Yes, sir. Yes, ma'am. Thank you,
I
ma'am.
have a small question. So, am I audible?
Yeah, tell me.
Yeah, so I just wanted to know, I mean, did you get a chance to look at the Surya Siddhanta? Even I haven't seen it, but I kind of came across it several places. I just was curious whether the Surya Siddhanta also refers to the heliocentric theory, or they say that the calculations in the Surya Siddhanta are very precise, like a lot of calculations about tilt of the axis and rotation periods and so on. So I think as far as mathematics is concerned, whether sun goes around the earth or earth goes around the sun, you can kind of come up with the equivalent theories which will, suit the both. But only when you come to the dynamics part of it, probably certain things change, like gravitational and so on. Probably they were not aware of the gravitational thing. But I just wanted to know whether Surya Siddhanta mentions the heliocentric theory. I'm not sure if you have come across.
No, sir, I am not. I am not.
No, I think there is a book written by S. Balachandra Rao about Surya Siddhanta, Satya. You're right.
Yeah.
There is a book written by S. Balachandra Rao. That book talks about all these things, mathematical things, and the overall. That's a very good book. It is available even in Kannada and English by S. Balachandra Rao, famous mathematician. Everybody can have a look at it.
Yeah, this is around 500 BC, Surya Siddhanta.
Right.
Even I haven't read, but a lot of people were mentioning that, so I thought maybe that.
No, it's now available in Kannada. It's available. Recently, it is released. It is available in Kannada.
Okay.
Sanskrit translations are available by S. Balachandra Rao.
Okay, sir. That's good to know.
Yeah, by the way, a very nice talk and a lot of information. Thank you so much.
Satya is
Thank
from
you.
Mangalore. Satya is from Mangalore.
Oh,
Nice to meet you.
Supriya, keep the time. Check the time.
Yes, sir. Yes, sir. I'm winding up. Thank you, Sridevi ma'am, for the wonderful session, for the information. I think everyone enjoyed your class today. Thank you very much for accepting our invitation and giving your time for us. Thank you, ma'am. Thank you, one and all, for joining us today.
Thank you, ma'am.
thank you to all of you and for encouraging discussions also. Very enlightening as well.
Thank you.
Yeah,
Thank you.
Surya Siddhanta, just a minute. Was it written in BC or AD? 500. I thought it was written by a student of Aryabhatta, right? I mean, maybe along with Aryabhatta. And that is the one which describes eclipses, if I remember right.
Eclipses are described in Aryabhattiyam, madam. But what Surya Siddhanta is another book. As you rightly said, Varaha Mihira Surya Siddhanta.
And Surya Siddhanta is in here. They wrote in AD after Christ. We got like Aryabhatta wrote Aryabhatti and Surya Siddhanta.
Okay, good. Thank you. Thank
That's
you.
all. Just yeah, so that people don't get confused. Please check the date. That's all.
Thank you, ma'am.
After Christ era. After Christ era, ma'am.
Thank you. Thank you.
Thank you.